Welcome to Study Loop.
In this question, we have a 1.4 kilogram model rocket launched vertically from rest with a constant thrust of 25 newtons until the rocket reaches an altitude of 15 meters and the thrust ends. Neglecting air resistance, we are asked to determine the speed of the rocket when the thrust ends, the maximum height reached by the rocket, and the speed of the rocket when it returns to the ground. So the cool thing about this question is basically we're going to be utilizing the exact same formula to calculate part A, B, and C, but we're just going to be using it in a slightly different way with different sort of conditions for each of the sections. So you'll see what I mean once we get into it. So starting off with part A, we're asked to find the speed of the rocket when the thrust ends. So that's going to be what we think of as the final speed. And let's write out some of our givens. So the initial velocity is going to be 0 because it's launched from rest. And the displacement is going to be 15 meters. That's really all that we know in terms of the kinematic variables, but this is not enough to calculate VF. We would either need to know acceleration or time. Since we have some information about the forces acting on this rocket, we can go ahead and calculate acceleration from that. So let's analyze the forces acting on this rocket. So we know that there's going to be a thrust force. I'm going to label that Ft, and that's going to be propelling the rocket upwards. And then there's also going to be a gravitational force acting downwards on the rocket. So now that we know the forces on our rocket, let's create an F net equals ma equation, and we can solve that to find acceleration. So the thrust force, we're just going to consider that to be positive. Let's take upwards to be the positive y direction. And then that'll put a negative out in front of our gravitational force since that's pointing down. And we can solve this for A by dividing by m. So we get Ft minus Fg. I'm just going to write that as mg divided by m. So to find acceleration, we'll just plug everything in. And once we follow this calculation through, we're going to see an acceleration of 8.05 meters per second squared. Okay, so now that we have that, we can go back over here. Now we have enough kinematic information to calculate VF. So we're going to select the kinematics formula that doesn't have time, since that's the only variable that doesn't appear in this list. So we're going to use this formula here. Since VO is 0, we can just cross that term out right away. And we're trying to find VF, so we're just going to take the square root of both sides to solve for that here. Okay, so we're just going to plug in, we're just going to plug in what we have. So 2, 8.05, and 15 meters. Okay, and the final answer that we get there is going to be 15.538. Or if we round and keep the appropriate number of significant figures, which in this case would be 2, that would technically be 16 meters per second. Okay, so that is our answer for part A. And then in part B, we're asked to find the maximum height that is reached by the rocket. So as I said, we're going to be using the same formula, just in a slightly different way. So what I mean by that is we know that the rocket, say it starts from down here, we know that the rocket travels upwards 15 meters to start off with. And then at that point, after the 15 meters, the thrust ends, but it's still traveling with a upwards velocity. So it's going to continue to travel on up to some maximum height, which is what we're trying to find. So we need to calculate what the distance from here to here is first, so that we can then go on to calculate the maximum height. So the final speed of the initial part, the part where we travel up 15 meters, that's going to be the initial speed of this second section of the motion. So that final speed just becomes the initial speed here. So I'm going to write the non-rounded form. Okay. And after the thrust ends, the acceleration is just going to be the acceleration due to gravity. So it's going to be negative 9.81 meters per second squared. And the final speed at the very top of the motion, where the object reaches its maximum height, has to be 0, because that's where it's turning around and a negative velocity becomes positive. So as I said, we can just use that same formula to find our displacement. So we're going to do VF squared equals VO squared. This time our VF squared is 0. We can take the 2AD to the other side. That becomes negative. And then dividing by negative 2AD gives us a formula for D. And so we can just plug everything in. The two negatives will cancel out on the bottom here. And the displacement that we get there is going to be 12.3 meters. So the total, the maximum height, is going to be the 15 meters plus the 12.3 meters traversed in that second part of the motion where there's no thrust and just the acceleration due to gravity. So H max is 15 plus 12.3, so that gives us 27.3 meters, or taking significant figures into account, that would just be 27 meters. So that's part B. And then in part C, we're asked to determine the speed of the rocket when it returns to the ground. So let's consider what each of our kinematic variables would be for the downwards motion. So this time we're thinking about the rocket starting up here, and we're thinking about its downwards motion towards the ground. So we know that the total displacement is going to be 27.3, or since that's downwards, we can put a negative in front of it. The initial speed is going to be 0 because we're thinking about that top part as the initial point now for this calculation, and we know that at the maximum height, the speed is going to be 0. The acceleration, since gravity is the only force acting on it at this point, is going to be negative 9.81 meters per second squared, and we need to find final speed. So we're going to use that same formula again, but rearranged for just VF. And if you didn't catch that the displacement was negative because the object's moving downwards, that's okay, except what's going to happen is that you'll just get a negative under the square root. Your calculator will give you an error. So it's important to try to take account of the directions. So the final answer here is going to be 23.1 meters per second when it reaches the ground. And that's our final answer.